Yeah, hi everybody. My name's Kevin. So today we're going to talk about SimCenter TestLab Neo in the Process Designer. And it's going to be kind of a mix of some new things that are new in 2406, and then as well as just some general usage tips and tricks. What I'm going to cover today is it's a small thing at first, but we're going to have a double click. So there's going to be a couple different ways to change the properties of your methods. And one of the nice ones we added for 2406 is a double click. And then I'm going to show how we did a little bit of easier way to search for the methods. And I'll talk about the syntax changes in block calculate and also the map calculator methods. And then I'll talk about using variables, which were new in 2406. And then we added semi-stationary averaging, so I'll show those settings. We added specifying a processing segment in absolute time instead of time. And then we've extended the octaves to include FFT-based octaves as well as real-time octaves. Then we added a couple new methods for Process Designer, a map calculator to do math on waterfalls, a sound power to do sound power calculations, resolvers to convert your resolver signals into RPM. And we also added mission synthesis in 2406. To edit the properties, there's basically 4 ways to edit the properties of a method. So in 2306, you could highlight the method and then go to the properties pane. So we can open the property pane and change the settings. We also added a double click. So now I can just double click on the method to get the properties. Or I can right click on the method and get the properties. Or I can highlight the method and go to the methods ribbon and click on properties that way. So there's 4 different ways to get to the method properties, and whichever you prefer to use, you can use. Why do we do this? It's a cleaner workflow. Fewer items on the screen. So if we're not going to need to go to the properties page to find the properties, we can collapse it, and then we get more real estate on the screen. And then you can still double click, right click, or go to the methods ribbon and find the properties dialog. So 4 different ways to do the same thing. If you're searching in the method library in 2306, when you type in signal, you find the methods that start with signal or have signal inside the method name. So we find signal generation and append time signals. 2406, when you start searching through the methods library, we're searching not only the method name, but we're also searching through the documentation. So we're looking for the descriptions as well as nicknames that were added. So one of the example was overall level. If you searched on OA or OAL, which some people call it, you'll find that same overall level method. We also added some syntax with the calculate methods. So this is true in the calculate method, the block calculate method, and the map calculator methods. Before, you had to have the help open and look at the help syntax before you could type in the formulas. And now we have this dialog that we can go into, that we can search in different categories. We can just type in the formula, and we can start to see the syntax. We can add items to the formula field just by using this dialog. So we added user process variables as well. When we go into the process ribbon, you'll see there's a process variables item here as well. In order to use it, we need to turn on expert mode first, advanced feature which requires activating the expert mode. You go to process variables, and when the expert mode is turned on, when I hover over one of my method parameters, I'll see a little grayed out area to the right that I can turn on to access the process variables. So this is turned on, and if I click it, I'll be able to use a pull down and then pick a method, process designer variable I've created. And here I've defined ones where I have my orders, which are 2, 4, 6, 8. I've got a tracking channel defined, minimum speed defined, a maximum speed defined, a speed increment defined, and the frequency resolution. And then it's part of this process. So if I have multiple items in my process that uses these parameters, they can all link back to the process variable. Then once I save the method or save the process, I can open it in a new project, adjust any of these parameters, and the entire process gets updated based on these. So it's a quick way to change the orders, a frequency resolution, or whatever you want based on different data you're processing day to day. Okay, so let me switch over to the software and I'll try to show some of that. So here I have TestLab Neo open. I have a process designer open. And then in the input basket, I have some data. So I have one run in my input basket that's got 3 differential channels. So it's got a triax, it's got a microphone channel, it's got a C-track channel, and it should have an engine taco. So let me show ways to change the methods first. Here, if I go to Spectral Map here, by default in Process Designer Task, the properties is collapsed. So if you want to edit the properties, you can expand that and change the properties here. Okay, so by default, it's going to be collapsed. So you can always access it again as popping open that pane, or you can collapse that pane again. I can also go to Spectral Map and change the properties here. Okay, so I can change the properties there. I can right-click on the Spectral Map, and I can change the properties. Or if I just double-click on that, you can change the properties that way as well. So 4 different ways to change the properties. And then the thing I showed about searching for signals, so if I wanted to search on the method library, and maybe I wanted to search on overall level, I can see I've got the overall level here. It also found some other things available too that maybe are in a add-in that's not turned on. That's why these are grayed out. If I search for overall, I can see that. And if I search on signal, for example, I can see all the things that have signal either in the method name or in the method descriptions. That's different than searching here. So there, it's only going to find the name of the methods. So if you're searching for something, it's much easier, I think, or better to search in the method library rather than just searching on the pull down, because it's only going to find the methods with those names. And it's also only going to find the methods that are turned on. If I don't have a license turned on, it won't show up in this list, but it does show up in the method library. And any of the add-ins that aren't turned on, they're going to be kind of grayed out. Okay, then I'll show the syntax of the calculate commands. So here's a calculate method. And if I look at this formula set here, I can go ahead and I can define a new formula, and I can click the FX, and then I start to see all the formulas that are available. If I want to search, so maybe I search, for example, a multiply. Okay, I find multiply, and then I can see the syntax of it, and I can use this to pick the items and insert in the formula. So if I pick maybe R1 or G, insert the formula, and it's going to multiply those two. So that's how that syntax looks. Some of the formulas I have here, if I delete this one, here I'm dividing by a scalar and converting it to speed. So that's using square brackets to define the new unit. And I don't want to take R1, which is the engine RPM, divided by 50 miles per hour. I want the resulting unit to be mile per hour. So it's important to put parentheses around the whole formula and then specify the desired end unit in square brackets like I did here. And here I'm just subtracting 2 channels. That's not too interesting. Here, this is kind of a neat formula. Here I'm going to do an if-then statement. If channel 3 is greater than 1.9 G, I'm going to multiply it times 0 and add 1.9 G. So that's going to replace any values above 1.9 G with 1.9. If it's less than 0.3, it's going to multiply it by 0 and add 0.3. So anything below 0.3 Gs, it's going to flatten it out and call it 0.3 Gs. And then anything else, it would be the values of channel 3. So there we can use this if-then statement to get rid of all the values above a number. I can also look at the block calculate command. And if I look at those parameters, and if I look at that formula set, I see something similar here where I can add a new formula. I can use this f of x button to find out what's possible inside this block calculate command. What I'm doing here is I'm looking for the channels that start with GIFF. So I have a triax here on a differential. So I'm going to look for all 3 of those for my overall levels, my second orders and my fourth orders. Then I'm going to do the vector sum for each of those. So I don't need to specify the differential XYZ channels separately. I can just find them all with a GIFF asterisk, store them in identifiers R1, R2, R3 for each of the function classes, and then use those in a vector sum formula. Later on, I'll show, this is the way in 2306 and earlier. Now most people would use the map calculator command and calculate the vector sum of the waterfall, and then do these calculations on the vector sum of the waterfall. Then you don't need 3 separate equations like I have here. I'll show that as well later on. Okay, so that's the syntax in the different calculators. If I look at the process here, I turn on expert mode. Okay, so expert mode is turned on over here on the right. I can look at my process variables. You basically can add some new rows here. I give it a name, and you give it a value. So here I have a value for orders, and I call them 2468. And you want to be careful of the syntax. If that's expecting commas or semicolons, you have to make sure you use the same. So here I added semicolons because that's what that method requires. Here I'm specifying a tracking channel, and I can either specify it by DOF ID or channel ID. So I specify it by DOF ID engine, which is nice because if the channel number changes, it doesn't matter. It's going to look for the channel with the DOF ID named engine. Then I can specify min speed and max speed. And I specified RPM here just because I know it's RPM. So if you've got a different unit or a different channel you're using that's not RPM, that's not going to work. Same thing with the speed increment, and I specified frequency resolution as well. Then I can see if I look at this method, for example. So there I've specified this tracking channel to be a design variable. If I turn that off, then I can go and pick one of these channels. Or if I hover over here, so you don't really see it until you hover. If I hover over there, this means expert mode is turned on. So I can turn that on and then pick something in the pull down, and I'm going to pick the tracking channel from my process variables. So there are defined process variables for tracking channel, min speed, max speed, speed increment, and down here for frequency resolution. Okay, so if I run this, I have the data in the input basket, so I can run this process. And if I look at my active analysis here, it's going to go through, and this is part of a drive up and a drive down. So it's just going to do the drive up portion based on the min speed and the max speed I set in the process variables. And then it goes ahead and calculates that data. So here, if I look at my differential data, here I can see I've got the spectrum map that was calculated as well as the average spectrum. If I look at the time data here, this is the time data. And this is the one where I removed everything below 0.3 G and everything above 1.9 G. So it flattened it out at 1.9 and below 0.3 and kept everything in the middle. Okay. So maybe if I want to reject this one and go to process variables, maybe I want to change this to be instead of 1 Hertz, maybe I want to call it 2 Hertz. Okay. And then run that. And now we should repeat the process, and now it's changed 2 Hertz. And it's using that in the spectrum average, as well as in the spectrum map for the vibration channels and the spectrum map for the pressure channels. It's done that, so now I can see all the data has 2 Hertz resolution. I didn't really mention that before, but here I have a spectrum map. And if I check that properties, you can see here it's using the frequency resolution variable. If I check the acoustic map as well, it's using this frequency resolution variable. And if I check my spectrum average, it's using the same frequency resolution variable. Okay, so that's one way to commonize it. I reject that. There's another way to do it too that doesn't use variables. I wanted to mention it in case people didn't know. But if I put a spectrum map, maybe add another spectrum map, I can highlight both of these now. And then I can go to the properties and I can change settings on both of them at the same time. So here it's 2 Hertz by default, so maybe I take that 8 Hertz, and maybe I want this time segment to be a 0.5 second close. So now if I check them individually, that kept 8 Hertz with 0.5 second, and the second one kept 8 Hertz with 0.5 second. So that's another way to do it as well. If items are similar, you can just highlight them together and change the properties in one go. Let me talk about the ribbon here a little bit. So here's a Process Designer ribbon. So if you're on display, you can change over to process. I can open an existing process. I can save this process to overwrite it. I can save it as a new name. Export's not interesting. It just exports a picture of my flowchart here. I can accept, so I can auto accept my runs, or I can manually accept my runs. If I've collected the data and timed that acquisition, I can save the result into a new run or the input run. That only works if I don't have any process data already in the run. So that'll work exactly one time. Automatic dry run's kind of neat. We added this, might have been in 2306 we added it. Basically, if I go to one of these methods here, and if I wanted to change something, it knows what channels are available to me. So for example, if I switch this to be tracking channel, let me turn that on. It knows what channels are available to me. So that what the dry run does, it walks through the process looking for all the data before it, so it finds it. In 2306, we would have had to go to this item, tell it to run to find all the stuff above it before we could set the channels. We don't need to do that anymore. It's as long as you have this automatic dry run on. If it ever gets confused, I could always go to one of these methods here, and I could always refresh. So there's a refresh here you could use as well. But it's not needed if you've got that dry run turned on. Include for processing. These are all the data that's going to be processed. And these channels have either used for processing or used for annotation. So annotation channels are basically for tracking. So those are going to be GPS channels, lowly sampled data below 512 hertz by default, angular velocity. So these are RPM channels, basically. Then everything else is going to be used for processing. If you wanted to have your RPM channels processed to get FFTs, you would just need to turn that on. But that's what used for processing is. You can get an overview of that by using the list processing data, and then you see for all of your channels what's used for processing and what's used for annotation. Process variables I talked about. Clipboard I can copy and paste. So if I wanted to, I could copy and paste items. Select, delete, undo. I'll talk about that a little bit, but you can undo and redo. Status, if I wanted to turn something off, I can either double click, or I can go to the properties and change it here. Or I could highlight it and change the status here and turn that item off or on, or I could bypass it. The properties I talked about, that's getting the dialog. If I want, I can pick an item and set the default parameters. I could also create a combined method. So this is kind of neat. Maybe I wanted to highlight all these channels down here and create a new combined method, and I'll call it new 2. Okay, so now that's kind of collapsed. So now I can just run through this method and I don't see these settings. And if I wanted to see the properties here, it can't change anything at all. So this is a way to hide the settings from your coworkers or maybe one of your customers where you don't want them to change anything. If you want, you could configure the parameters. And maybe I wanted to expose something. So here, maybe under spectrum map, I wanted to expose the frequency resolution, for example. So now I can change the frequency resolution here. So that's been exposed. So maybe you wanted to expose some things you want people to change, and that would be under this configure parameters. You would come under here and tell it to expose or not expose any of the parameters you want to expose. Okay. If I go back to my process here, and if I undo, so now I get rid of that. So I have created a combined method, and then I can undo it if I don't want. Okay, so that is basically an overview of the Process Designer. Let me go back to my slides. We can also define segments, and we added a new feature in 2406 that if you wanted to define your processing segment using absolute time, you can do that. And one of the challenges was maybe measuring data with SCADA's RS hardware independently with a web app. You want to import those different data and merge them together. So we added the solution of segmenting based on the absolute time to synchronize those different separate throughput files based on absolute time. The benefit is import any number of runs with proper absolute time, and we can merge them together to process them together. One bad thing is currently in this current release, which is the first one, we can't do it graphically with our interactive display. So you need to go and manually set these start segments in absolute time format rather than doing it visually from the display. So that's one drawback. So if I show segments, just in case people didn't know, if I look at my input here and I turn on one of my channels, I can set my segment with Alt, like that. Or if you hold Alt and Control, I can set multiple segments. So there it's set the segment. Okay. So then if I were to process this data, I would get an average spectrum for each of these segments stored in a run, as well as the waterfall stored into a run. I have two different run names, and they would be annotated with the segment start and stop. Or if you wanted, you could always give it a suffix here. And then rather than annotating the run with segment times, you would give it these names. We also added semi-stationary averaging. So if you wanted to have a relatively slow run-up and you were at each speed for a certain amount of time, we can do averaging at each speed. And that works with tracking on channel, so speed channel, for example, or tracking on time. So here's an example where we have a relatively slow drive up. We can do averaging at each one of these speeds. And the settings are, you'd have to turn on semi-stationary averaging, and then you tell us the number of averages, the maximum number of averages at each tracking point, the minimum number of averages. Here I've got some notes here. Software stops with the averaging when the next target is reached. So maybe if I'm at the first speed, it doesn't have time to do 5 averages before it hits the next speed. It's going to go to the next speed and start calculating. So the minimum number of averages means if it found 2 averages at the first speed, it would be saved. If it had less than 2 averages, it would discard that tracking point, and that line would be missing in the waterfall. It would go to the next tracking point. And then you could also do a range enabled, and then at each tracking point, you could set a delta. So this would be plus or minus 2.5 RPM around your speed at that tracking point. And if it's outside of that range, it would not be included in the average. So that range is, it's a delta, so plus or minus 1/2 range around your tracking point. If we tracked on time, it allows you to do a lot of overlap processing. And this isn't something we can do in Classic, so this is new in Neo. So here we're going to set 8 Hertz resolution. So our frame size for 8 Hertz resolution is 1/8 of a second. And we're going to set a very fine tracking increment of 0.01. And then it's going to march through the data every 0.01 seconds with a roving average. With that frame size is 0.125 seconds. It's going to average throughout there based on the number of averages and what overlap percentage you give it. Let me show that as a demo. So if I switch sections here, and if I switch to stationary averaging, and if I add that data to the input basket, okay, so now it's just got 2 points of tackle. And if I run this, and I want to look at the blocks in the waterfall to see how many averages are in the blocks. So I'm going to switch to my list view here. And if I expand this active analysis and look for my waterfall that was calculated. So here's my waterfall. So here I highlighted the blocks in the waterfall, and I can see that they had 20 averages. So remember that each one of these tracking points had 20 averages. So let me reject that. Now I'm going to change something. So now I'm going to turn on range enabled here. And I'm going to pick a range of 40 RPM, I believe. If I run that, so now it's going to skip one of the speeds. One of the speeds isn't going to have 5 averages within a plus or minus 20 RPM range, and it's going to be skipped. And then some of the blocks will have less averages as well. So if I look at this and look at my waterfall blocks again, So there it has 5 blocks now instead of 6. So it skipped a block. So it skipped a block around 800 RPM because we didn't have 5 averages there, within plus or minus 20 RPM because I had a range of 40 specified. And you can see here some of the speeds have less than 20 averages, so 18 and 14, for example. So that's semi-stationary averaging. We also added another octave method for FFT-based octave in 2406. So in 2306 and earlier, we had time-based octaves. So when you had the octave analysis add-in, we had time-based octaves, so real-time octave calculations that were done. And we expanded that to include some additional octaves. So we added 1/6, 1/12, 1/24 octave formats. But then we added also frequency-based octave spectra to be similar to what we had in classic TestLab. And it doesn't need the octave analysis add-in. It's part of either the signature analysis add-in or the sound quality analysis add-in. And then what we did is that we merged the settings from classic that you found under Tools Options General into this one method. So in classic, you have to go to Tools Options General, pick which type of octave you wanted to use, and also set the minimum number of spectra per octave band you would keep. So you tended to lose the low octaves because you didn't have enough frequency resolution, and you can adjust that parameter. Now this is all available in the method as well. So here in the method, we can pick the octave filter type, the octave ratio map, and that's the octave ratio, as well as the minimum lines per octave. And as long as you have 4 spectral lines within the octave band, it will keep that octave band. So if I show that in the software, so if I switch to that section, okay, so here I'm passing the pressure data to an octave map, which is time-based, octave average, which is time-based. I'm passing the acceleration data to an octave map that is FFT-based. Then I can see here, I can set ANSI or ideal for the octave filter type, and then I can pick base 2 or base 10, and this is where I can set the minimum spectral lines. If I look at this data here, okay, so I can see that the pressure data would have been real-time octave because I passed it to a real-time octave, and the acceleration data would have been FFT-based because I passed it to an FFT-based calculation. Let me go back to the slides. Okay, so that's octave extensions. Map calculator, drive channels have been calculated on spectrum maps. So here we've got a method here where I'm going to pass the spectrum map to the map calculator. Here's an example where we're doing a vector sum. And we can do averages of channels, min or max envelopes, or vector sum. I'm not designed to calculate across runs, so we really want to keep the z-axis and the x-axis the same. So I want to make sure that the tracking axis is exactly the same. So the input is really expecting a single map method. So if I try to point a second spectral map to the map calculator, you're going to get a warning and it won't let you do it. But it's really designed to have a single spectral map going to the map calculator, and then you can do waterfall map. It's expecting the z-axis and the x-axis to be the same. So the points along the tracking axis need to be the same, as well as frequency resolution and frequency range should be the same. So if I show that, it should have hopefully a map calculator section. And let me add some data to the input basket. So I'm going to pass the acceleration data into a spectrum map. I'm going to pass the pressure data to a spectrum map. And then for the map calculator, I'm going to have an identifier finding the 3 differential channels, X, Y, Z. And I'm going to do a vector sum of that triax. I'm going to do a max envelope of the triax, and I'm going to do a linear average of that triax as well. And I'm calling a unique point ID here. And because I'm doing math on the XYZ channels, I've set the directions to be none. Okay. So if I run this channel and look at my active analysis, it takes a little bit, and then it should do. So there it's done. And I can see here is this is the average of the XYZ channels on the differential. This is the max envelope of the XYZ channels, and this is the vector sum. And I can compare that perhaps to the individual channels. Okay, so that's map calculator. If I go back to my slides, note about the tracking axis in the block calculator. All inputs used in one formula should have the same x-axis. Output is always the tracking axis. In the map calculator, all input blocks used in one formula should have a common x-axis. We kind of force this because you can only send a single spectrum map to the map calculator method. And then the outcome is going to keep all available axes. So it's going to keep your time axis, your tracking axis, as well as all of the other tracking and static channels. And we're going to try to keep this new functionality where we keep all available access in all future releases. So as we come up with different methods and modify different methods, we're going to keep the same behavior where all the axes are going to be kept. Okay, we also added sound power. I'm not going to do an example of this, but we've added a sound power library. You can calculate the background noise level, the sound pressure level, as well as the sound map. We've also added narrowband results, which we can't do in Classics. We've added these narrowband results that you can look at some of the data with. Okay, so maybe for engineering purposes, it may be interesting to look at the sound power in the narrowband. And this method doesn't support, if you do an FFT based, it doesn't support K1 and K2 yet because those are expected to be octave blocks. So if you wanted to correct for K1 and K2, you need to use the sound power calculation, not this one that's FFT based. Okay, so this does include K1, K2, but not the narrowband option. Okay, then the last thing I think I'll show is Resolver. But here we can take Resolver's data that's been pulled off, and it's got usually a sine and a cosine channel, and it may have an excitation channel as well. And we can use that to calculate RPM. So we have this Resolver conversion method that's available to us. And the output mode can be RPM or angle. Speed calculation can be automatic or user-defined. And by having user-defined, you can set how many pulses per rev you have. And as that increases, you'll get more resolution. So it's a way to change the dynamics of the calculated RPM. And then you would specify the cosine channel, specify the sine channel, specify the excitation channel if you have it, or if you don't have the excitation channel, you just specify the carrier frequency. Okay, so if I show that, so if I switch to the Resolver section here, if I add that data to the input basket, if I look at that input channels, so there I have a cosine signal, I have a sine signal, and I have a excitation signal. Okay, so then if you want, I could always look at this in a stack. I can change a view of that. Then I can see here I've got one of these channels is the cosine, one of these is the excitation, and one of these is the sine, as well as I have an RPM channel I'm not going to use for the map. If I wanted to check that, one thing I could do, if I didn't know the carrier frequency, I could always run it through the spectrum average and then just look at the excitation signal and get its FFT and then look at the frequency to see what it is, if you don't know what it is. And then we can go to the resolver here. I specified my cosine signal, specified my sine signal, specified my excitation channel. So this is the cosine, this is the sine. Okay, specified my excitation signal, and I found out it was 9708 hertz. So I did a spectrum average first to figure out what that frequency was, then I specified that. Okay, so there I did the resolver. This is the result RPM. And this was using an output speed calculation mode of automatic. If I wanted to do this again, if I wanted to change that perhaps to user defined, then we can specify how many pulses per rev we want. So this is a way to improve or change the dynamics of the RPM calculations. If I run that again, and if I look at that results, okay, so this resolver signal would be slightly different. And if I accept that, resolver here, and look at my tacho moments here, you can see how that tacho moment is changing in some of these calculations. So the one that has more moments at the low speed and the high speed, where I modified the automatic pulses per rev to 6 pulses per rev, and if I increase that, I would start to get more tacho moments available to me. Go back to the slides. So that was a resolver. And I think the last thing, I'm not going to show it, mission synthesis. So we've added this in Neo now, and we've got these methods available to us inside Neo Process Designer for doing mission synthesis. Well, great. I think that's all I wanted to show. Let me go back to the last slide here so you can see our email addresses. Okay. You're welcome. Have a good day, everybody.